All right. Hello, everyone. My name is Ben Jones. Thanks for dialing into this call. I'm real excited about this presentation. I'm going to be able to walk you through my latest book that just came out this last week, and it's called Avoiding Data Pitfalls. And it's really all about ways to avoid some of the common mistakes we all make when working with data. It's such a common thing. It can be tricky, as you all know. And so I've written a book almost to help myself if I were to be able to go back in time and let myself know some of the things to maybe not do, as well as some of the things to do. I think that's a part of being highly literate, right? Is knowing the sorts of things to avoid as well as the sorts of things to do. But I'd like to start with a quick little poll. And so, it's about the topic of seasonality. And as we all know, seasonality is this characteristic of a time series where we see a regular or predictable sort of fluctuation in the time series. Probably on a calendar year basis. It could be maybe even monthly or a weekly kind of a seasonality. But traditionally, seasonality by the meaning of the word means that in a 12-month period of time, some series goes up and down over the course of that calendar year. And as it turns out, for the folks on the line that are in Amazon, I'm actually based out of Bellevue now, and Washington, right across the lake from your headquarters in South Lake Union in the Seattle neighborhood there. And so as people who live in the area know, we call Seattle Crane City. And that's because there's so much development going on, particularly in your own neighborhood right there where the office is. As you all know, those of you who drive into and out of that office right there off of Mercer know that construction is a constant and has been for almost half a decade now, or a little more than that. So let's talk about in this little quiz I'd like to give you. And by the way, to participate in the quiz, just take your phone and go to slido.com, SLIDO.com, and I'll show you how to log in to our little poll, okay? But just to kind of set the stage for this little quiz, I'll give you to get the juices flowing. The idea here is that when anyone wants to build something to their house, or whether it's a commercial structure, maybe you're going to be a restaurant adding a kitchen, maybe you're a person like you or me trying to add a porch to your backyard, or it could even be a skyscraper or a football stadium, and everything in between. The idea is you have to file an application with the Seattle city. Like in any city around the world, those are sorts of things that we see there. And so what we notice if we take a look at that time series is that it tends to be, if you look at the applications, that in the past anyway, you've seen peaks in the summer months, June and July, and then you've seen these valleys or troughs in the winter months, December, January, February. And so this is an example of seasonality. But every application actually has a category that goes along with it. It could be a category for a commercial, or maybe it's a category, maybe the application is for a home, like a single family home, or maybe an apartment complex, so there's different categories. So if we look at the time series based on these half dozen categories here, you can see what I mean. This is essentially looking at seasonality of these permits by application type, by what we call class type, permit class, over the course of over a decade of applications here in Seattle. So I'd just like to ask a simple question. And you aren't experts in this data, and neither am I. So it's just give me your gut take again, just to kind of start the conversation a little bit here. And that is, the question is, which permit categories have exhibited seasonality? Based on what you see in this area chart here, which of those categories on the right would you say have exhibited seasonality? Here's how you vote. As I mentioned, go to slido.com and then just plug in ATUG, A-T-U-G, okay? So, and then you click on join right there. And I'm going to push the poll live to you all. So it's out there now. I just did that here on my phone. And so you can go at the top of the page. You can do this. Oh, by the way, if you're on a computer, you can go to sli.do on like a browser. Or if it's on your phone, I think slido.com gets you to the voting a little better. So anyway, try it out. And I'm going to wait a minute here to kind of see some votes coming in. You should see at the top there's an audience Q&A and there's a live polls. Let's just use it for the live polls because Dimitri is going to help us out with the Q&A, and we can use this video conference platform we're using right now for Q&A. And I'm going to try to end about at least 5 minutes early to be able to field a handful of questions there. And by the way, I'm actually wrapping it up at 10:45 today, just because I have an appointment I need to make it to here in the area. So awesome. I see a vote coming in. Thank you. There's a couple. Great. So I'll give it a couple more minutes there. Yeah. So again, question, I'll just go back one slide so you can see it. So while you're voting, you can take a look at it maybe instead of the sign-in screen. Yeah, I just want you to take a look at these and let me know which do you think have a high degree of seasonality to them. Okay. So we'll do that. And again, just to kind of get a little challenge off to you all here to start off the morning. Great. I'm seeing a few more come through. Thank you for everybody who's taken a minute to vote. And yeah, just a fun little quiz. Again, no need to worry about getting it right or wrong. It's just really to kind of to feel ourselves out on this data set here and kind of see what this is telling us. Awesome. Seen lots of votes come through now. We'll come back to this. All right. So first of all, I also want to say thank you to you all. Now, my name is Ben Jones, as I mentioned. I worked for many years at Tableau in the Fremont neighborhood, right across the lake from the headquarters there. And I got a chance to lead the Tableau public platform. It was a great opportunity for me. It's a free offering that people around the world use to tell stories with data that's in the public domain. And so I got a chance to work with journalists, with bloggers, with students and professors, and really kind of see data come to life that way. I left last year, about a year ago actually. I had written the book Communicating Data with Tableau, the O'Reilly book, where I got a chance to talk about how I think you can use Tableau well in order to visualize data. And then, as I mentioned, this presentation is all about my latest book that just came out last week called Avoiding Data Pitfalls, which I think is a very important topic to cover for anyone who uses Tableau or any other software tool in order to be able to visualize their data, or programming language for that matter. As I mentioned, I left last year to start Data Literacy, which is a training company. This is all about helping people speak the language of data, tool-agnostic frameworks to help them become more confident, whether they're reading charts and graphs that other people have made or exploring raw data for themselves and communicating with others. So that's what I do now, here based out of my downtown office in Bellevue, and then part-time here at home as well. But my message to you all is first to say thank you for what you do. I don't know if this book would really get in the hands of as many people as it is getting into their hands without the work you all do, providing this obviously the world's largest retail platform and site for people to be able to find content that's relevant to them. That picture on the left there is from my book launch party, this is last week on Thursday in downtown Bellevue. And that person that is pictured there with me is my wife, Becky Jones. And Becky Jones used to be Soliday. She works at Amazon. So she's there. She's been on the Renewed team for a number of years now. She's been at Amazon for about 7.5 years. And that's me and Becky at the launch party. And as you can see, it was so exciting for me to go home after the party and after dinner with the family. And then just at the end of the day, as I was kind of calling it a day and crawling into bed, I happened to log on to notice that the book was already a bestseller, so I was kind of surprised, but also excited. I guess it was the #1 new release in the business communications category. So, with that kind of shot to the arm, it was really nice for me as an author to see the book getting out there and having people, notice it that way. So couldn't have done it without you all. So again, thank you all for all the work you do to help people like me get their messages out there. This is my family. This is Becky and I and our 3 high school teenage boys and our little dog, Winston, who might make a showing at some point in time here, depending on how brave he gets. But for some reason, when I talk at a screen, he likes to come on over and say hello too. So we'll see if he drops in. But there he is. We were on a trail. This is to a beautiful place called Spectacle Lake, which is just outside of Pelham, maybe about a 45-minute drive east of Seattle. And so we went on a beautiful hike. But I started to notice in all the hikes that I was on that there were these amazingly funny, sometimes warning signs, maybe not so funny, I don't know. This is one by Cold Creek Falls in Bellevue, where I live. And on the other side of the sign is a big bowl-shaped depression in the hillside that evidently is a sinkhole, which supposedly means the earth can completely fall away from you if you step into it. So needless to say, I won't be stepping into that hole anytime soon, but I did think the sign was interesting. Also, a few years back, I went on the Timberline Trail, which for those of you who know is a trail that circumnavigates Mount Hood in Oregon to the south of me. And that is by the town of Bend, fairly close to it. And as my friends and I came around the corner, we noticed a sign posted to the wall that simply said, "Don't do it." So that was a little bit of an ominous warning for us. And as we went a little bit farther beyond, we noticed that there was a washout and a bridge had been carried away by an avalanche in the wintertime. And this was a few years ago. I believe it's been fixed since then. It was the Elliott Creek crossing around Mount Hood that had been completely wiped away. And so now you had to kind of rope all the way down, and this is looking vertically straight upward with a heavy pack on. And needless to say, we didn't do it, but we did take a different trail that took us a long time to get around, probably about a 3-hour affair that could have just been a 15-20 minute bridge crossing. So, needless to say, these trails, these treks, we go on these backpacking and hiking adventures, have their share of risks and cautions and places along the way, people that have written before that are telling us what to do, what not to do. And so there's these warnings, and they're helpful to keep us safe. And I got to think about also, I was aware of the fact that, similar kind of a warning will be found in pretty much all the ancient wisdom texts, no matter what religion that you're talking about. Some section in there, this is from the Dhammapada, which is a Buddhist text, that talks about paying attention to someone who's paying you, who's warning you about things not to do. So this quote says, if you see someone wise who can steer you away from the wrong path, follow that person as you would one who can reveal hidden treasures. Only good can come of it. Let them admonish or instruct you, or restrain you from what is wrong. And so I'm not that wise person, but I am trying to compile as much as I can a list of the things not to do that I've stumbled me mostly into myself over the last few years. And so I got to thinking, though, what are the warning messages out there about working with data? And I noticed that a lot of them had to do with pie charts. So like death to pie charts here. This is Cole Knaflick, a good friend of mine in storytelling with data, or Walt Hickey of 538 calling pie charts the worst chart in the world, or here's Bernard Marr saying, people stop using pie charts. And, granted, right, like this one here, some of them are pretty bad, and I definitely would agree with that. But as I noticed that, I got to thinking that, if I published a perfectly good bar chart, maybe everybody would think it was fine because it's not a pie chart, and so they wouldn't question it. And I got to thinking, well, possibly that could be hiding a whole lot of issues behind it. So let's take this simple one, for example, that I made a while back. And actually, this is from Baltimore's Department of Transportation. Baltimore, the city of Baltimore in Maryland, on the East Coast of the United States, here where I live, has a tow department, and they tow cars and vehicles of different types to 2 different tow yards in the city. And then they capture those details about the car, and they put it out there online, and you can download it. And so I did, and I started to visualize it and realized that, basically the top 4 makes of cars that were towed in Boston in a 5-year, Baltimore in a 5-year period of time were Honda, Ford, Chevy, and Toyota. There we go, 1, 2, 3, 4. And those are pretty common vehicle makes. I wasn't too surprised about that. But as I looked down farther, I noticed that I started to see something interesting, like Toyota in all caps, or Honda in all caps, or Ford in all caps. And so, these are just the top 26, and you can see ending up with Volkswagen there at the end. But as I looked further, there were actually 899 of these in the overall list, vehicle makes, including, things like this is the raw data itself, and what you can see it looks like here, but it would include things like, Ford, but also, as we saw, Ford in all caps. But if you go further down, eventually you'll find Forf, or even Ford with 3 R's, Ford, right? You're going to see Peterbilt, the semi-truck, but also Peterbilt, and even Peterbutt, and not to mention good old Pete. And then you can find Mitsubishi, and you can find Mitsubishi. So there you have it. And you can even find burnt car on the list. So that must have not been a good one. But there you have it, right? Like 899 different makes and models of different spellings and cases and everything. And so you even find 36 different ways of spelling the word Volkswagen. Here's a word cloud that shows them based on how many times each spelling appears. And so as I was laughing about this, I realized that I'm not even sure I was really aware how to spell it properly. I probably would have spelled it with an O, like the word wagon. But anyway, there you have it, right? 36 different ways of spelling Volkswagen. So what does this all mean? Well, what it means is that if you take on the left-hand side my original sanctioned, compliant bar chart, there you go, right? I thought that there were 5,200 Hondas, but on the right, you can see when I clean up the data, there's actually 7,700 Hondas when I take care of all the different ways of spelling Honda. Ford, that's a 50% increase. It isn't a little bit, like a tiny little increase. It's a massive increase in terms of the number of Hondas that have been towed in the city. And also notice that the top 4 aren't even the same, right? It's Honda, Ford, Chevy, Toyota on the left. On the right, we got Honda, Ford, Toyota, Chevy. So Toyota leapfrogs Chevy. And that's interesting, right? And even if I look all the way down, I'll notice that Volkswagen goes from number 26 all the way up to number 11. And that's because there are so many ways to spell Volkswagen that it got spelled wrong more often than the other vehicle makes. And that would make sense. We would expect that. But you can see how on the left-hand side, I would have been pretty misled. I wouldn't have even had Volkswagen in my top 25. And it turns out it almost even cracks the top 10. So, again, just a simple example, of how the chart type might not be the most important thing. Sometimes you might pick the right chart type, but the amount of issues that you see leading up to the choice chart moment can really make or break the analysis as well. And that was kind of my impetus behind wanting to write this book. It took me 5 years to write it. And I started back in January of 2014. And, started to 15 actually, started to kind of compile these lists of things that I noticed were going wrong when I would work with data. Also, when I would teach my students at the University of Washington. So let me walk you through them. I categorized them into these 7 different categories. And not sorry about all the alliteration. So I figured people are going to either love the alliteration or hate it, but you notice that it's all same letters there, right? But let me just give you an example of each one, just for you to get a sense of what's in the book, and hopefully you find it helpful. But also, maybe if you don't want to buy the book, at least you'll walk away from today with some good warnings, good examples of things to watch out for as you work with data here coming down the road, whether it's Tableau or any other tool for that matter, by the way. I don't think any one tool is or isn't going to cause you to fall into these pitfalls. I think that it's embedded in the nature of the activity itself. Some of the tools can help steer you clear, can help at least flag you to some of the issues here on this list, but you're not going to be completely free with any tool, in my opinion. Okay, so epistemology is a fancy way for talking about the way we think about our own thought process. And so sometimes we can just think about data the wrong way. Sometimes we just don't really think about it clearly, or we walk into it having the wrong idea of what data can do for us, even before we start to analyze it or make charts and graphs. So an example of this was, the Northridge earthquake back in the 90s. I grew up in California, and I remember it being woken up in the early morning. And, I think tragically 60 people died in that earthquake. And this is a bridge that collapsed not far from where I lived at the time. And so, it would have been difficult to study earthquakes at that time, or to get, as a citizen like myself, my hands on good quality earthquake data, but not today. Today you can go to the United States Geological Survey website, download over 100 years worth of earthquakes. And if you do that and make a simple line chart, you'll notice that earthquakes that are magnitude 6.0 and up seem to be on the rise in the last 100 plus years. And so, that seems like it would be an alarming thing, isn't it? More and more earthquakes every year, and that seems like a trend that I wouldn't really want to think much about, right? That's kind of disturbing. But as we stop and think about it, it probably doesn't take much thought process to realize that this isn't really a true trend. It's just that, in fact, if we were to break it up by group or by magnitude, we notice that the rising trend is really in the smallest magnitude group here, from 6 to 6.9. The 7 and O's are pretty flat. And it turns out because, even way back in 100 years ago, if there was a 7.0 magnitude earthquake, people knew about it. No matter where it was recorded. But some of these smaller ones, 6.0 and above, especially if they're in remote locations, may have been missed. But then over the course of the 20th century, we installed all these amazing, eventually digital seismographs, created a worldwide network, and just essentially dramatically improved our ability to detect some of these smaller, still large earthquakes. And so then we're not really looking at the actual increase in earthquakes that have happened. We're looking at the ones that have been captured, recorded, reported, and stored and made available to us, right? So, in other words, if we think about it in terms of the San Andreas Fault-like gap between data and reality sometimes. So we think about data as like the truth, right? The very thing that we're trying to measure, exact one-to-one match with reality. But the truth is, it's just not like that. Even with simpler things, like let's take this amazing baseball player, Hank Aaron, who I loved. He was more like a mythical character to me. I was a kid growing up in the 80s. He had already long since retired, but his was the number 755 that everybody was chasing. has since been passed by Barry Bonds, but seemed untouchable, unreachable at the time when I was a kid growing up collecting baseball cards. And so you might say, well, 755 home runs, like there's no gap between reality and that data point. Like that's a simple fact. And so, there's an example then of, an example where, data is a one-to-one match with reality. And I would actually, I thought that too, but then I looked into it a little more closely and I realized that, well, actually, that number does not include the 6 home runs he hit in the playoff games that he played in, including the World Series, when it mattered the most, right? Or also the 2 he hit in all-star games against the best pitchers in his time, in his era. And even times where he played for the Indianapolis Clowns of the Negro Leagues, he hit home runs for that team too. That's a professional league, a professional team, not included in the 755 number. So my point here is just that, there's always some kind of a gap between data and reality. Sometimes it comes down to something like this, operational definitions. Maybe it wasn't clear to you or to me that 755 home runs is just the regular season home runs that he hit while playing for the Major League Baseball team that he played for, the Atlanta Braves. And so, again, gaps between data and reality is so common. It's just good for us to know that going into it so that we don't fall into that trap of thinking that our data is like the exact perfect thing. Well, technical trespasses has to do with all the measuring, storing, transferring, joining, all those data munging, data collection processes that we go through in order to get data into our hands. There are so many steps there and equipment and people along the way that can introduce or inject error or issues into the data. So an example of that is this is the Fremont Bridge, which I used to cross every day on my way to the Tableau offices there in Fremont, not far from Amazon headquarters in Seattle. A side note, it's actually the bridge that goes up and down the most, and the drawbridge that goes up and down the most in the entire country. It's pretty low, and it's rather old, over 100 years old for U.S. standards, I guess. And so every little sailboat that goes through it feels like requires the bridge to go up and down. But turns out it's a nice excuse for if you're late for a meeting in the morning. But in any case, if we look at this bridge and you stand on top of it like I am right here now, you'll notice that there's a bicycle counter on the bridge counting bikes going back and forth. The Seattle Department of Transportation likes to keep track of that to promote ridership around the city. And so I downloaded the data. They make it available. You can see how many times bicycles have crossed the bridge, and you can download that and check it out for yourself, which I did one day as I was presenting at a luncheon not too far from the bridge, and I wanted to show them how to use Tableau. And so we took the data here from this is the Socrata portal. You can see the raw data, what it looks like. There's 2 columns, one for each side of the bridge, the east sidewalk and the west sidewalk by day. And you can see the number of bicycles that it measured. And as we measured it here, and as we plotted it on a line chart in the luncheon that I was presenting to, again, I didn't really know going into it that we were going to see this, and I hadn't really looked at it ahead of time. I must admit I was a little bit ill-prepared. But anyway, there I was standing in front of about 50 or 70 people showing them this line chart. And I mean, obviously the thing that jumps out at you kind of is inescapable is this huge spike on one side of the bridge only. And we said, wow, that's interesting. And again, I didn't know the answer to why it was happening, but I threw it out there to the group and I said, well, why do you think it is happening? What's your theory as to what caused that? And they had interesting ideas, like maybe it was bike to work day, or maybe there was a race or some kind of bike club that rode through the area. They didn't cross the bridge the other way, evidently, right? So that caused an interesting kind of nuance to the conversation. But in any case, we went on with the presentation because I didn't know. And so then later on, maybe about 15 minutes later, a gentleman in the back of the room waved his hand and had his phone holding up in the air. And he said, I know, I found out what it is. And, we said, oh, well, what's the reason for that huge spike? And he says, evidently, it's just equipment malfunction. So there's a Seattle bike blog where this blogger said, Monday appears to smash the Fremont Bridge bike counter record. Update, probably not. And so he went back and forth with the Seattle Department of Transportation, and they were taking a look at it. And the person that worked for the city said, all we know is we went out and changed the batteries, and then these crazy erratic readings went away. And there were spikes that occurred for 4 one-hour periods of time there on the 23rd, 25th, 28th, and 9th of April. By the way, as a side note, if you go to that website today for the bridge data, and you download this entire series, you won't find those spikes in there. They replace them with averages, which I think is an interesting separate conversation altogether. But in any case, what really hit me about this example is that nobody, myself included, even thought to challenge the reality of the spike. Similar to the gaps between data and reality, like I just talked about, we all thought it was real. All of our theories, all of our ideas, brainstorming involved actually way more bikes crossing the bridge. Not one of us threw out there that, maybe actually there's something wrong with the machine itself. And so then, again, this is part of this process of collecting and storing data, that there's a lot of technical glitches that can happen all along the way. Okay, I talk about joins in this section too, where maybe the values don't match up and they're missing an important point. And I create a little fictional example there of a woman who's doing some marketing analysis for her firm. So lots of technical trespasses. Keep moving along here. Mathematical miscues. So when we do math, a lot of times even just simple aggregation, all we're doing is just summing up or counting the occurrences of a variable, summing up some quantitative value. And, just simple math, right? So there's lots of ways we can get even that wrong. And this story comes from a presentation I gave a couple of years ago down in Los Angeles at USC and University of Southern California. I was presenting to some journalists who were there for a fellowship. And so I was presenting them, kind of training them on how to use Tableau. And so I was at this time writing this very book, in this very chapter. And so I found some data from the California Health and Human Services website right here. That's infectious diseases by county, year, and sex within California. I think going back about 5 years or so. And so I downloaded this data set. Now, I played with it a little bit, not a lot, but a little bit. And so I was aware of one pitfall, and I was going to kind of, lead them to it, if you will, and help them fall into it, not being devious, but just kind of helping them maybe feel the weight of the pitfall. So here's what it is. So I essentially started off by saying, we got the data set. Let's just make a simple bar chart that tells us how many total cases are we talking about of infectious disease in California. Oh, it looks like it's actually a 14-year period of time there from 2001 to 2015, okay? Turns out it's about 15 million. If you just take the number of cases and drag it to rows, or columns actually, you get a total of 15 million. Okay, there you go. And so they said, okay, 15 million, that's how many cases we're talking about. Now, as we went on with the training session, we were looking at it by gender. So we kind of made a note of that, 15 million total cases, and we looked at it then next by gender. And as you can see, what happened is, as we looked at it by gender, we realized that, well, wait a minute, there's 3 different values in the gender category. There's male, female, and total. And I think since California has added non-binary, something like that, so they're continuing to develop that category, but to kind of match where we are today in the world we live in. But for that period of time, going back to 2001 up until 2015, there was male and female, but then also notice there was total, right? And what that means is there was another row for every single county and every disease and every year. There was 1 row for male, 1 row for female, a 3rd row for total, which, as you can see, is just male plus female, 50% of all of the total. In other words, we realized, oh my gosh, our first answer to that question, 15 million total diseases, is wrong. It's actually more like 7.5 million, half of that value, because we were double counting for the total row. And so there we go. I was satisfied that I taught them all about this pitfall to avoid, and to be careful about those total rows every time they find them, and have to look for them, right, in a data set before they start answering questions. But then later on in the session, actually maybe about half an hour later, we were looking at cases by county. And so we made a map in Tableau. It's amazing how easy it is to make a map by just double clicking on county, and there we go. But then a person in the class raised his hand and he said, well, hey, Ben, what does that mean that there's 1 unknown in the bottom right corner? What does that mean? And I said, oh, good question. I don't know. Let's click on it. And so we did. And it popped open this dialogue. And I noticed right away that California was unrecognized as a county in the state of California. And as soon as I saw that, I kind of had to stop and laugh at myself, because it really hit me what it meant. Because I grew up in California, and there's no California county. There's New York County in New York State, but there's no California County in California. And so what was happening there is they were providing essentially another set of total rows, which is, instead of the county, it's the sum of all of the counties, right? So then what that means is the 7.5 million number was actually twice as big. And the real number was more like 3.7 million total cases of infectious diseases in the state of California over that 14-year period of time. So our original answer to the question was actually 4 times higher, not twice like I thought. And I had to, again, kind of laugh at myself that I fell into the pitfall in the same session I was trying to teach them about the very same pitfall. It was kind of a double whammy there. So statistical slip-ups, I mean, doing stats, that can be tricky business, right? I mean, some of us went to school and we got a formal education in statistics, and that's great. And others like me, I didn't. I did engineering school, and there's very little stats actually involved in my curriculum back in the 90s. But in general, we can break statistics up into 2, I guess, like main subcategories: descriptive, where we're just summarizing a data set, and then inferential, where we're trying to infer properties of a population from data just collected by a small sample or sample of the population, right? And so you might say, well, descriptive statistics, like that's pretty simple. No one's going to get that wrong. Plenty of pitfalls in the inferential side of things, and I do cover those in the book too. But I'd like you to see how even on this descriptive side of this fence here, it's still very easy to get it wrong. So here's an example. When we talk about central tendency, this is mean, median, or mode. Oftentimes when we say that to someone or talk about the averages and things like that, what they immediately hear in their mind, whether it's true or not, is that this is what typical is. And so let me give you some examples of when that's not the case. In fact, we'll look at a single example. We'll talk about football player data. So we're watching football right now, college and NFL, those of us in the US who are interested in that sport. We get to watch football. And these football players are tracked and measured, and so it's not uncommon for in fact, you can find that data online about every one of their height, weight, age, the jersey number they have on the back of their shirt. All kinds of data is available online about players. And so I went a couple of years ago to the NFL website, okay, and I downloaded about over 2,000 players into a simple spreadsheet. Took a while to copy and paste it all, actually scrape it. But this is what I found when I look at the averages for the NFL. Okay, the average NFL player is about 25 years old, just over 6'2" in height, and weighs about 244 pounds, and makes $1.5 million in salary. Okay, and if I told you that, and then you were to bump into an NFL player at random, you would probably, like me, if you're like me, assume that they're going to be, relatively close to every one of these. In other words, this is a typical player. But if we look at the distributions of each of these 4 variables, salary, age, weight, and height, and I've mixed them up here and I've taken away the labels to try to quiz you a bit. So, which do you think they are? And I'd ask you to just take a minute, take a look at them. So which do you think is salary? Is it A, B, C, or D? Which do you think is age? And what about weight? And how about height? Which of them? You can see the distributions are very, very different. These are histograms in which we add up and group all the different players. So the height of the columns is the number of players that fall into a bin or a little bucket between the min and the max of each of the variables. And so you can see the one on the top left is pretty much like a bell-shaped normal curve. And it turns out that that one is actually height. So the height of the players is pretty Gaussian. On the top right, we see our age has a skew to the right, a positive skew, meaning there's a handful, a very small number of players that seem to play to a really much older age than a lot of the players in the league at any given time. Okay. In the bottom left, we have weight is this funny multimodal humped camel shape here, in which we've got different players at different groupings of weights. And then salary, where we've got, most of the players clumped to the left and a tiny number that is so far to the right, you can't, and so small, it's just one, you can't even see the bar over there. Players that make over $20 million, and there's a few of those. And so if we take a look at this multimodal shape, we see that if you break it up by position, that it's more or less normal. It's just that we have different positions, different players that have different body types based on the sorts of things they're asked to do on the field, whether they need to run around fast and change position like wide receivers, or whether they need to, try to win control of the line of scrimmage in the middle with these other larger players on the line of scrimmage. So interesting that we see, these different distributions, and ultimately the takeaway is just that, not all variables are created equal. This is a fun one here. The uniform distribution is basically the numbers on the back of their jerseys, right, from 1 to 99 is pretty uniform, and that's a bad dad joke. So sorry there, but there you have it. Okay, a couple more to go here. I want to make sure we have a little bit of time for Q&A. So when we do analysis with data, we go beyond just simply looking at averages and distributions, right? A lot of the times we're looking at relationships between variables and how we think about those things and correlating and trying to find underlying relationships and causes and such. If you haven't read the book Thinking Fast and Slow by Danny Kahneman, I recommend you do that. He's a hero of mine, someone I really look up to and admire his work and his research. He was worked for I believe the Israeli army for many years in the 60s, probably in 70s, studying how we think, these little heuristics or rules of thumb that we apply. And they did a research analysis with some study participants, which I think is really interesting. And what they said is, they asked them to come up with a reason why the following statement is true. And the statement is this: the counties in which the incidence of kidney cancer is the lowest are mostly rural, sparsely populated, and located in traditionally Republican states in the Midwest, the South, and the West. And so they would ask study participants to explain why that is. And they would typically come up with interesting reasons, I'm sure you can imagine, like, well, it's healthier out there, there's less pollution, maybe. And so, those are some reasons maybe that people gave about why someone who lived in a rural environment would have a smaller incidence of kidney cancer. But then they showed different participants the follow. And this is, by the way, this quote is true, it's factual. But so is this one, which is really where it gets interesting. So they would ask them, and now consider the counties in which the incidence of kidney cancer is highest. And they would say these ailing counties tend to be mostly rural, sparsely populated, and located in traditionally Republican states in the Midwest, the South, and the West. The exact same profile of a county is also linking up with those counties that have the highest kidney cancer rates. And so they would come up with interesting theories here, like, maybe they don't have, access to good healthcare, or people would throw out all these reasons why, and they try to justify the statement. But what's really happening is just that there's a funnel shape going on here. So if we plot population of the county, smaller counties to the left, larger counties like LA County or Cook County, where Chicago is located, to the right, and the overall 15.9 per 100,000 kidney cancer incidence rate is this line going through the middle. We notice that these larger counties tend to hover around the line with so many people there, but the smaller counties kind of fan out. And that's because there's so few people there, right? If you look at Pulaski County, the county with the highest incidence rate, there's only 4 cases there, right? Or Polk County on the lower end, the smallest, there's only 4 cases there too. So just one more or less number of cases will shoot that small county from the top to the bottom. And so it's really just a question of small sample size there, and we tend to be blind to that. So anytime you see this funnel shape, when you look at sample size or population and some variable, like in this case, kidney cancer rate, just be aware of that. That the value you get, the rate you get, or the average you get is a function of, and it can be dependent on sample size. Another way of kind of making that point is to say, if you move to Lost Springs, which is a population of 1 person, right? And I don't know, let's say Daniel Kahneman, who won the Nobel Prize, let's say he lives there and you move there. And if you think that means you have a 50% chance of winning the Nobel Prize, then you've fallen into the same trap of the small sample size, right? And so I told him about this. I sent him this analysis I did, this dashboard, and I was thrilled to get a reply back from him. Said, thanks, that was fun, DK. So there you go. Kind of made my whole month there right around the time I started writing this book. So pretty excited to get an email from Daniel Kahneman. There you go. Even if that's all I got. Thanks, that was fun, DK. A couple more to go here. So graphical gaps. So when we chart data and we make visualizations, it's easy for us to be misled by what we see. So an example of that is the Edgar Allan Poe's works that he published by year. So Edgar Allan Poe, as you know, many of you probably do, is an English kind of horror writer, short story writer, as well as poet. And one day I wanted to find out how many pieces of literature he'd written over the course of his career. And so there it is. And so if you take a look at this and say, which year did he publish the fewest works? If you're like me, you'd say 1824 and 1825. But actually, this is looking at it as a discrete variable, the year. And so you can see that a couple of years are missing, 26, 28, and 30. They're missing. If I make it continuous, actually the situation gets worse, because now it looks like he published 6 works in 1826, And it looks like he published 11 works there in 1828. And when you get to 1830, it's really puzzling to notice that it looks like he published 8.5 works, if you look at where that line crosses there. But so if we change that to show missing values, we see that those years are 0. And it wasn't very obvious for us at the very beginning. And I didn't really go out of my way to doctor this chart to make it confusing. It was the default. And so if you might say, oh, well, why does Tableau default to that? They shouldn't do that. Well, maybe. I mean, it's hard for the software developers to know exactly how you want to deal with missing values. And so they give you the choice of how to handle that. But think about like elections or the Olympics. Those are not happening every single year. And so, you wouldn't want the line to drop down to 0 every single time. But the point there is just there's so many ways when we first visualize the data. If we just take a look at it and we don't really look closely or deeper, we'll get the wrong answers pretty easily. And so there's a few other examples of those. You can see what we should see as zeros. Those are the years in which he published a fewish number of works. Maybe even switching it to a stacked bar would be better, like that, almost where we stack each one of these works of literature, and we can see those years that there aren't anything in there. But pie charts, yeah, there are certainly pie charts. There are issues with them, like this one, in which the slices don't add up to 100. Or these ones where it's hard to see what's going on and how the slices are changing. And if you make a simple bar chart, you can see right away the pattern or the trend. On the left, the slice is getting steadily larger. On the right, the slice is getting steadily smaller as we go around clockwise, right? Or in the middle, they're all basically the same with maybe a bit of noise in there. And I can see why so many people hate pie charts, but they can also be very helpful. Like, let's say, for example, we wanted to look at crime in the city of Orlando, Florida, and we wanted to tell our audience that theft is half of the total crime. Well, which of these 4 ways of visualizing that exact same data set tells you that theft is half? And to me, it would be the pie chart really conveys the notion of half better than any of the others. Certainly better than the bar chart. So pie charts have their places. If I wanted to show that theft, burglary, and assault together make up 3/4, 75% of the crime in Orlando, we'd see that the pie chart, again, is by far the best way to make that singular point. It isn't as good to make other points, like which of these two is slightly larger than the other. That can be difficult. So it isn't like I'm trying to say pie charts should always be used. I just think they have their place. I love this quote by Leland Wilkinson. Pie charts have been reviled by statisticians unjustifiably and adored by managers unjustifiably, right? So there you have it, okay? I kind of look at it, the way I see it is charts are like letters. There's E's, where we see those all the time, and there's Q's, J's, X's. We don't see those too often, but it doesn't mean we get rid of them. It means they have their place in the overall lexicon and the language, and the tool belt of the person trying to create words, just like for us making charts and graphs and dashboards. They have their place. We just need to be careful when to use them. But no need to banish them, to call them evil. They're not. They're just not as useful as others, and they're useful only maybe in very specific cases, like with the Q after, that has to be followed by a U. The last one, and we'll wrap it up here, is this design danger. So I notice people use a lot of colors when they show dashboards. Dashboards being multifaceted views of data like this one. But you can see if I were to take the Boston Marathon results and put orange as New York and Austin, and also as people who finished between 3 and 4 hours, those are unnecessarily conflated there. And I see, for example, people creating dashboards like this that to me seems so exhausting, even just to look at it. There's color misused throughout here, right? There's red and green, which some people can't even tell the difference about those. But there's also colors used in different ways, like blue here and blue there, or green here and green there, and they mean different things in the same dashboard. I see this a lot with every dashboard tool, actually. So I tend to try to challenge myself to limit my color palette, to use only one color palette if I can. Not always possible, but that's my goal. I know that if I do that, people are going to find the display a lot more easy to understand and interpret. So we can see errors of commission where we do things wrong, or errors of omission where we forget to do something or fail to do something useful. And I think actually the Edgar Allan Poe chart did fall into this trap of an error of omission. I missed an opportunity in this version of it, because this doesn't capture anything about the ethos or the attitude or the mindset of Edgar Allan Poe, does it? But if we flip it upside down and make it red, and then maybe add his image or his handwriting, his signature, does a whole lot more to me to capture the feel, right, of what it means to be reading a work of his, a literature of his, right, a poem or a short story that he wrote. So we wouldn't want to miss those opportunities. The eighth pitfall. At first, I only had 7, but there's actually 8. And just to wrap it up here, the eighth is that I wrote this entire book, and I was sitting right here in this very room, and I realized that all of the quotes to start all of the chapters, 9 chapters, every single quote was written by a man. And that was shock to me, because I consider myself, a feminist and an ally to women trying to make strides in STEM. How could I have done that? I was really shocked by that, and that was a good wake-up call for me. And so I went back and I was able to switch that up, like I think I originally would have. But I started wondering, like, well, how did that happen? I'm not trying to assess blame. I think I own it, right? But I noticed that, when I found quotes about data, like this one right here on the Timco Spotfire blog, you can see that there are very few females in there. Right? It's the same thing with this one, 20 inspirational quotes about data, 19 male, 1 female, 0 non-binary, 100 greatest data quotes here, 93 of them being words of males. So we inherited this world where, the males are the ones that have the voice in the data space, STEM in general. And so we get to choose if that's the world we continue to carry forward and pass on to our generation, or if we want to change that. And sometimes we have to be deliberate about that. And so I needed to go back and make that change. So the 8th pitfall is our baseline. What's your baseline? Is it biased? Who is in your data? Who is represented in there? Who is not represented? Let's go back to our quiz. So this whole thing about seasonality, let me just sign in here if I can find it. Let me go back to let's see here. ATUG, here we go. So what did you all say here? Just kind of curious. Let's just check it out. Live polls, here we go. Okay, so 39% said all of the above. That's consistent with what I have seen elsewhere. Fred Hutch, where I presented earlier last week, and other places. It looks like they're all like that, doesn't it? It looks like, yeah, man, these are all seasonal, right? Just look, they all go up and down, like it's a big wave, up and down, up and down. But actually, what if we switch the order of these colors? Like, let's take this blue one, for example, the single family duplex that's on the bottom. Let's move it to the top. And now we can see that these ones on the bottom, like, let's look at commercial, for example. Do you see that same seasonal wave? Or does it look more like just like noisy bumping around, right? It does to me. It does to me. So in other words, you take a simple visualization. A lot of people, I think, when they see an area chart, they assume that the lines are behind each other, like superimposed on each other. But they're not. They're actually stacked on top of each other. So effectively, all these other color waves, bands, they're riding the roller coaster that's given to them by the blue segment on the bottom. And so it's really common to, again, fall into that pitfall. And I did too when I first saw it. And then I switched it around. I was like, oh my gosh, wow, actually, no, I misunderstood that from a simple view of the data. So a good reminder for us all. Also, sometimes instead of area charts that are stacked, we might want to just superimpose lines instead. Okay. I have a gift for you. I'm going to get it through, actually, the way you want to get it. I made a companion guide. And so what you want to do to get this is go to my website, dataliteracy.com. It's a simple check. What it is, I took those pitfalls, those 8 pitfalls, and I put them into a little checklist that you can print out. You can use as a PDF. You can, check it if you want, just as a way to kind of like take a look through and see if you need to check on something, if you need to kind of be careful about using data. And with that, and one other thing for you all, I'll end with thanks. That was fun, BJ. There you go. Just like Danny. There you go. So I'd like to thank you all, especially Dimitri, for inviting me. You can use this code AmazonTug for any training offering. I should be posting my Q1 offerings coming up here in the next week or so. So if you want to learn about my offerings, then you can use that code. Feel free to pass that along to a friend or family member who's trying to get better at working with data. Okay, here's where you can get a hold of me. And I have time for maybe 1 or 2 questions. So can you, Dimitri, let me know if anybody has any? And I don't see any in the chat. Let's see. Do I see it in here? Let's see. Well, if there are no questions, and it seems like maybe there aren't, I would encourage you to reach out to me. You can follow me on Twitter at Data Remixed, or add me on LinkedIn if you like. If you have any comments or questions, feel free to reach out to me directly via email. And again, thank you for all you do for helping me get the word out about the book using your platform. And Yeah, I really appreciate your time today. I hope this was helpful. If you get the book, I hope you really like it. I hope that you get more out of it than you have to pay to get it in terms of value. That's my hope and my goal. All right, so I'll sign off then. Dimitri, I guess I'll turn it back over to you. Is there anything else you want to close with, or anything else that you'd like to say?
No, I think all good. Yes, I will share this record because some people can't attend. I will just upload to the broadcast and will share with you. And if you can send me the deck, it will be great because I will upload deck with the record.
Okay, great. I will send that over to you. And so thank you for all your help setting this up, and to the folks watching the recording. I hope you enjoyed it. And for the folks that are calling in live now, I hope you have a great rest of your week. For the folks here in the U.S., happy Thanksgiving. I hope you have a wonderful time with your family.
Thank you, Ben. Have a good day.
Thanks. You too. Bye, everyone.